I put it above the x. Distribute across, we get 2x to the 4th plus 2x cubed plus 0x squared minus 10x. We got that, right? Excuse me. Subtract everything through, and I get a 0, which is fine. Drop down to 9. Now, what happens here then is that I can't, my degrees down below have become lower than what I started with, so that's my remainder. The negative 9 is my remainder. That's it. So it's minus 9 all over this. And that's it. It's all, and you're done.
Oh, wait, the remainder is over the dividend?
Yes.
Okay.
Yep. Because that's, I mean, think about it. When you had if you're remember how the example we had the other day, we were dividing by 12. It was like 8 over 12. That's how that works. It works the exact same way. Okay.
I put it over underneath.
Oh, yeah. Don't do that. It's an easy fix, though, right?
Yeah.
All right. So, are we okay with long division then? Excellent. Let's do the fun stuff. Let's add to this with synthetic division. Synthetic division is the most awesome thing in the world. Synthetic division is awesome. Oh yeah, also you'll notice on the calendar I've updated what we're going through this week. We will be done with polynomials on Friday. Well, actually, I'm sorry. We have to be done with them a week from, I'm thinking geometry. We will have to be done with them by next Monday. I have 5 days left of material to go through, and Friday it gives us time to do some of the review stuff. I have a pretty decent review thing that I've done in the past with this unit. It works out really well. The only downfall is that this might be the only time I have to do some sort of an assessment on a Monday. I apologize for that, but if you want to plan it out, I can make sure that I'm here in the morning in case you guys have spare questions and whatnot. I can get in here a little bit earlier. You guys stop in and whatnot for that. It's the very rare occasion. It might only happen once, if not maybe only twice the entire school year that could ever happen. But with Tuesday then being the day before Thanksgiving, a lot of people tend to be for those long weekends and who would like to be here an extra day if they don't have to be. That way, I don't want to do it on Tuesday just because the attendance rate on that day is rather the Tuesday before, because we only have 2 days next week. So it's a lot of people don't tend to show up on that day because you've got a 5-day weekend. Sometimes people turn into a 6-day weekend. Some people actually turn into a 7-day weekend, which actually becomes a 9-day weekend. So yeah, it works out like that. So this week, what we're going to do then, we're going to power through the last bit of polynomials. And believe it or not, once we understand how to use this synthetic division, the rest of the week is basically using this. And for some of you guys that I've shown a little bit of what synthetic division actually looks like, it's stupid easy. You're adding and multiplying. But the idea of what does it mean that you're actually doing is what's cool. So here's what happens.
What are we all testing on Monday?
I know. Basically, it's chapter 6 in the old book. I'll get into polynomials.
Oh.
So what happens here is we're going to use something called synthetic division. When we divided out before, we used the long method. And that's it's okay. And you guys saw it's not that difficult, but it's very time consuming. It's very tedious. With synthetic division, it's stupid fast and stupid efficient. Here's what happens. Synthetic division is a process by which you divide polynomials by other polynomials. And what you're going to do is you're going to be dividing by zeros. Now, in this case here, I'm going to do 2 different examples. One with the term x minus 2 and one with the term x plus 3, which means the 0 for x minus 2 is what? 2. The term is x minus 2, so the 0 would be 2. The term is x plus 3, so its 0 would be? Good. So here's what we do. We're going to divide this junk by the zeros of that. Here's what you do. You write down the coefficients. 1, 2, -6, and -9. And now we draw this little half rectangle. And what we do is we divide by the 0. So if my term is x minus 2, my 0 is 2. And I place that here. I know that you guys like procedural math because nothing changes. The replication process you're good at. Here's what you do. You drop the 1 here. Take a deep breath. Okay. 2 times 1 is what? We write that here. What's 2 plus 2? What's 2 times 4? What's negative 6 plus 8? What's 2 times 2? Negative 9 plus 4. You just divided synthetically. What's the answer? Here's what happens. Notice you started with a third degree. When you divide it out by a singular degree, it drops it a degree. Your answer here is x squared plus 4x plus 2 minus 5 over x minus 2, because that's your remainder. That's synthetic division. You're using coefficients, multiplying and adding, multiplying and adding. Isn't that a lot faster than long division? Long division wasn't difficult, but this is really, really fast. Okay?
Why would you put it over that?
Because this was our remainder. If
Oh,
we didn't
I
have
get
a,
it, I get it, I get it.
if we didn't have a remainder, that last value would have been 0. Let's do the exact same. Yes, sir.
How do you know that you can only drop it down to 3?
That's the rule. It always drops it a degree. Because if you think about long division, if you did this long division wise, how do you turn an x minus 2 into an x cubed? How do you turn that into that? What do you have to multiply by? An x squared. It drops it a degree. And that's the process. Every time that you synthetically divide, every time you do that, you drop 1 degree. And there's going to be a reason why we're able to do that, because we're going to use synthetic division for factoring because it's really, really easy. And Lindsay's going to roll her eyes and say, no, well, you say that about everything. And then I'm going to say, believe me on this one. And you say, you say that also about everything. And I'm going to say, but I'm not lying this time. And you say, oh, but you said that last time. Have we heard, have I got this right? Yeah. Let's try it again. Do the same thing with the x plus 3. Okay? The biggest idea is that you have to remember that when you're dividing using synthetic division, you have to divide by that, that 0 of the term. Okay? So if I'm going to divide by x plus 3, what's my 0? Negative 3. So that goes on the outside. Coefficients, 1, 2, negative 6, negative 9. 1 down. Drop the 1. Negative 3 times negative 1. I'm sorry, negative 3 times positive 1, excuse me. Add them together, you get negative 1. Negative 3 and negative 1 is 3. Get a negative 3 here. Is there a remainder? No. So your answer here is x squared minus x minus 3. Which base? Yes, sir.
I'm a little confused. Where are the red numbers in the box coming from?
We drop the 1. Negative 3 times positive 1 is negative 3.
Okay.
And then I add them going down, I multiply going up.
Okay.
So these are multiply, these are add. And it's the same thing every time. Does that make sense? So basically what this tells me is that x cubed plus 2x squared minus 6x minus 9 is divisible by x plus 3, which means x plus 3 is a term of it. Synthetically dividing brings things down a degree, which allows you to factor something quicker and go on from there. Okay? And then we'll get to more and more of that as we get along. Moral compass? Are you okay with that? Are you lying? Okay, let's try another one. X cubed minus 8x plus 3. Again, I'm going to divide it by the term x plus 3. What do you think you have to have in order to do this correctly? What did we have to have in our long division problems? Placeholders. What do you think you have to have in these? Placeholders. It's a third degree polynomial, which means it should have 4 terms. But it only has 3 right now, so we have to write it out as, well, we're going to divide by the 0. What's the 0 of x plus 3? Negative 3. My coefficients are 1, 0, negative 8, and 3. Bring down the 1. Negative 3 times positive 1 is 0 plus negative 3 is negative 3. Negative 3 times negative 3, 9. Negative 8 and 9 is 1. Negative 3 is 0. Which means you have
Wait. Well, how come you wouldn't do like x to the third minus 3x squared plus x?
because every time you synthetically divide, you bring it down 1 degree. Remember, if you wrote this out long form, x cubed plus 0x squared minus 8x plus 3. If I was going to divide that by x plus 3, what do you have to multiply x by to turn it into x cubed?
X squared.
We just divided by just using coefficients. Every time you divide out, you drop a degree. So there's your answer. Basically what this is telling you that if I multiply x squared minus 3x plus 1 times x plus 3, what do you think you're going to get?
3x to the third or something.
Look at that. Because x plus 3 is a factor of it. The reason why it's a factor is because the remainder was 0. All right, let's try that one. Excuse me. X to the fourth minus 16x squared plus x plus 4. Fourth degree polynomial, which means I should have 5 terms. But in this case, I only have 4. Where do I have to put a placeholder? At the x cubed. Very good. What's my 0 of x plus 4? Negative 4. One, 0, negative 16, 1, 4. Yay, procedural math. See how fast it is once you get going at it? It's really, really fast. It's a great tool to be able to use. So you get x cubed, 4x squared, plus 1. And that was your answer. Yay. Yay. Oh, hey, if any of you guys wind up going towards to go to Prairie Ridge this weekend for the football game, let me know if you need better directions or anything. I grew up out there. And if your families need a place, a good restaurant or something like that, there's a bunch of them right around there that are really good. That's what I'm here for. I'm like a tour guide. Yeah, Prairie Ridge is the newer, that school was built in 98, 99, something like that, I think.
So it's pretty new.
It's newer. It actually, it actually has air conditioning. So I think it's them and South are the only ones in 155 that have air conditioning. Sure. So one thing I want you guys to see here is now we're going to factor a polynomial. I'm going to factor a polynomial given a 0. It says f of negative 3 is the 0. So what's the 0? Negative 3. What am I going to put on the outside? Negative 3. It tells me that the f of negative 3 equals 0. That means that it is a 0, which means if negative 3 is the 0, what's its term?
X plus 3.
Very good. If negative 3 is your 0, your term is x plus 3. Remember, I've been talking a lot about terms and zeros. You're going to continue to hear that a lot because now we're going to use this process of synthetic division to factor. Because once we know 1, 0, we can synthetically divide to find the rest of them. It's the same thing. So our 0 is given to us, negative 3. Tomorrow we'll talk about how do you find a 0 to start with. We have a third degree polynomial. Excuse me. Third degree polynomial should have 4 terms. We do. Don't need any placeholders, so I fill in the blanks. 2, 11, 18, 9.
This is different than all the other ones, because this one has, A is bigger than 2. I mean, A is bigger than 1.
That's still the same thing. We got 5, negative 15, 3, 9, and a 0. If you don't get 0 at the end, you done goofed because they told you it was a 0. What happened? What happened? Oh, it was supposed to be negative. That's why. I saw your face go, huh? Like, oh, what'd I do? I knew it was a 0. I just got ahead of myself. So that means that if negative 3 is a 0, the term was x plus 3. This now becomes 2x squared plus 5x plus 3. Yes, sir?
So there will always be a 0.
If it's a term, yes. Now, it said factor this, which means we can factor this further. What's 2 times 3? What times what is 6 you add together to get 5? 2 and 3. So you get a 2x squared plus 2x plus 3x plus 3. This synthetic division took a 4-term polynomial, x cubed, and it looked like something you might be able to factor by grouping maybe, but it was unfactorable. So they gave you a 0 to start with, and you were able to factor out that x plus 3 portion, got you to a trinomial that you can factor. Take out your GCFs. Take out your GCF. So now we had this x plus 3 from earlier. The reason that I had this x plus 3 was because of what? It was a 0 to begin with. Okay? And now I have an x plus 1 and a 2x plus 3. So you just used synthetic division to factor a 3rd degree polynomial with 4 terms that looked like you had no idea what to do. Because there was no GCFs, there was nothing you could factor out. There was no grouping that could have been done. But they gave you a 0 and you went for it. That's what we're going to be able to do here this week. You do the same process basically over and over and over again. Okay? One of the zeros of the function, I'm trying to show you guys a bunch of different ways they write this. One of the zeros of the function blah, blah, blah is x equals 2. So they're telling you the 0 is 2. So if the 0 is 2, what's its term? Very good. So I know that it's telling me that my 0 is 2. So my 0 is 2, which means its term has to be x minus 2. and I want to use synthetic division to find all of the other zeros, which means I'm going to get all the other terms, and therefore find the zeros. I pull out the coefficients again. 1, -2, -9, and 18. What's your first step in synthetic division? Bring down the first term. 2 times 1 is? Which means you just, if you factored out the x minus 2, you were then left with x squared minus 9.
But why wouldn't it be 9x?
Because there was a 0 for the x. Remember how they go in descending order? It's x squared, x, 9, then remainder. So now you have x squared minus 9 and x plus 2, or excuse me, x minus 2. What are all of your zeros then? Well, 2
And then plus or minus 3.
is minus 3. It's a quick way to factor. What are your tails doing on this one? Yes, sir.
It says like the final zero is all you can do is like if you can find another zero.
Yeah, it'll tell you. It'll tell you whether it's factor it, find the zeros, or whatever. What are your tails doing on this one?
This.
Up, up,
Yeah.
down, up. Their tails are down, up. Here's -3, 2, and 3, which means it's doing this. Rough sketch of the graph would look like that. Remembering your dances. Do it. 2 examples. All right, let's see how we did besides, adding. And seriously, as you go through these things enough times, you're going to make a dumb mistake by, forgetting to write down a negative or something like that. Or that, 1 is not a 4. I don't know. I know that I have a 0 so I have an x minus 4 for a term, and then I have x squared minus 4x minus 12, which means I get x minus 4, x minus 6, x plus 2, which gives me 4, 6, and -2. It might not be a bad idea, as you're factoring and going through these things, work with your zeros. Notice how once I knew that I had a 0, I wrote down the term. Get in the habit of doing that. Write down your 0. Oops. If 4 is going to be a 0, write the term down right away, because it's going to be one of those things that's going to help you out as we continue on with these. All right. Excuse me. Same deal on the other one. Third degree polynomial. I've got 4 terms, so I don't have to get any placeholders. 10 is a 0 because it told me it is. 2, -14, -56, -40. 2, 20, 6, 60, 4, 40. 0. 2, 6, 4. So then I have x minus 10. Oops. Let me show you a trick here. Here you get 2x squared plus 6x plus 4. Take the 2 out. If you're factoring that further to find zeros, since this has a scalar of 2, does that 2 have any bearing on the problem? No, get rid of it. Take out the 2. That 2 has no, you don't bother with it anymore. But what times what is 2? You add together, you get 3. So you have x minus 10, x plus 1, x plus 2. So you have 10, -1, and -2.
Can't you just tell because the first 2 terms you divide it in half it? That's how it
What do you mean?
I don't know. I just like saw like a pattern.
For what? How are you getting? What do you mean by something? By cutting something in half?
Never mind.
It doesn't. I think this isn't right though. Let me check this.
Does it end on the right?
Quiet, you.
You always end off, and then I'm like, wait, do I do the next problem or do I
You should always do the next problem.
just always go past what you said?
Sure. It's good for you.
What? It never ends on the right number.
It never does.
Because then I have to sit there and think about.
Okay, no, and then I always like have to like redo it, like did I do it backwards? I'm like, did I like mess up?
Emma, what do you think the best
Yeah.
play was in the World Series?
Huh?
What was the best play?
The best play?
Yeah.
The final play, obviously.
I thought it was when Ezekiel Elliott made a great catch. He like went up on the bleachers.
Who's Ezekiel Elliott?
You don't know
Not
him?
on
He's an
the-
outfielder. He's an outfielder, right, Brady?
I can name you like 5 of them.
Do those.
But I'm right.
Yeah, just add on to it. Now, one of the things I will say is that
Grandpa Ross.
so far what we've done is when you got to that, when you dropped it a degree to a quadratic, when we dropped it down to get to a quadratic, those were pretty much factorable pretty quick, or rather quickly. What is one thing that you can do if you get to a quadratic that you can't factor? Bless you. What is one way of factoring that works to find zero? Quadratic formula. Don't forget quadratic formula can show up. Doesn't hurt. Alright? Unless you're getting stabbed in the head by a smiley face, and then it's really hurting. Yes, ma'am. Yes, ma'am.
Pretty sure you're starting like 40 through 57 evens.
Wait,
Yes.
It's always ends on the always ends on
But this one ends on the right number.
Are you
I-
sure?
I know, I always think I mess up. I'm like, should I go like one problem?
Yes,
over just
you should
to
always go
get
further.
it?
It's good for you. And I'll even put this up here for you because I know you guys are just dying to look at it. Yes, sir.
is that the old book?
Yeah, it's the old book stuff. It's the same page from yesterday. Same page from the other day. Here's the start of it if you guys want to look at it from here. Give you a little bit of time. You've got plenty of time. Excuse me. I believe they were find all the zeros for all, or factor them and find zeros, I believe. That's what it said. Factor the polynomial, given 1 0. So for the first 4, you're just writing down the factors. The second 4, you're writing down all the zeros. And then 56, you got to figure out the missing term. It's pretty easy. See if you can figure it out. I have faith in you.